Hey guys, welcome or welcome back to another Anaya's Lectures video. Today is going to be a chemistry one, and today we will be talking about chemical quantities. So, chemical quantities, specifically we want to talk about the mole. The mole is just a chemical quantity. I know it sounds confusing, but the mole is the same concept as how 1 dozen is 12, right? Or a pair is always 2. 1 mole is always 6.02 times 10 to the 23rd. Okay, either 23rd, this number, it could be particles, meaning it could be atoms, it could be ions, molecules, etc. It's just particles, okay? And this number was actually made by a man called Avogadro. This is his number. He was a scientist who discovered that 1 mole value of any substance, any element, any substance is always 6.02 times 10 to the 23rd number of particles. Why is this even useful in the first place? Well, it's actually useful in a lot of cases, especially when in chemistry, like if you have mass and you want to figure out like exactly how many particles is in 5 grams of water. You can find that out using the conversion of moles, or in 2 liters of oxygen gas, how many particle numbers is there? It's always through moles. And so anytime you want to find out particle number and mass, you'd always have to go through moles, etc. Now let's practice a little bit. The first concept I want to go over is the concept of molar mass. Molar mass is just the addition of all the atomic mass units in one compound to find out the total mass. The way it works is that you have calcium nitrate, or CaNO3 The way it works is that you add the atomic mass units from the periodic table of each of the elements and then figure it out. So calcium, I know calcium from the periodic table is 40. That's its atomic mass. And then I know nitrogen is 14. And I know oxygen is 16, but there's 3 oxygen, meaning that you apply the 3. There's 3 16s technically. So 16 times 3. And then the whole thing, there's 2 nitrates, meaning that whatever number this is, you multiply by 2. Anyway, so then you get 40 plus 14 plus 16 times 3 is 14 plus 48, which is 62, times 2, which is 124. 40 plus 124, and you get 164 grams per 1 mole. This might seem like not that important information, but it's actually really important when you're doing conversions. So, and we'll see that actually in a little bit. So that's very simple, molar mass. Something a little more difficult is how many moles of iron oxide are equivalent to 3.26 times 10 to the 22 molecules of iron 2 oxide. Well, I know, so it's asking me about moles, and it's given me number of molecules. If I look here at the diagram, I have particle numbers and I want to go to moles, meaning that I'm going to have to convert particle numbers into moles using Avogadro's number. So the way it works is that you want to set up your dimensional analysis table. So I have 3.26 times 10 to the 22nd molecules, and I need to convert it into moles, meaning that I know I want to bring molecules down here so I can cross it out, meaning that 1 mole is equal to 6.02 times 10 to the 23rd molecules. And that way, for my table, molecules and molecules cancel out, meaning I'm left with my numbers and my final unit of measurement, which I wanted in. And then this, your final answer, once you do your calculations on your calculator, should be 0.05415 or 0.05 moles. And that's your final answer. Really simple. One that's a little more confusing, is just one extra step, is this number 3. It says here, how many molecules are there in 0.525 kilograms of potassium sulfate? Well, so I already know that potassium sulfate, first things first, I want to write the chemical formula of potassium sulfate. Well, I know that potassium is K, sulfate is SO4, -2, K plus 1, meaning that it's K2SO4. That's the chemical formula. From this chemical formula, I'm going to figure out the molar mass of potassium sulfate for my calculations, okay? So I know potassium is 40, and then there's 2 potassiums, meaning I'm going to do 40 times 2, which is 80. And then sulfates is 32. And then O4 is just 16 times 4, which is 64. You have to add these two up, which is 32 plus 64 is 96 plus 80. 96 plus 80 is 176 grams per 1 mole. Now, this isn't a final answer, but this is very critical information that I'm going to use in my dimensional analysis table when I'm going to start it. Now, it's given me kilograms, and I need to find number of molecules. Well, I'm going to go here. I have the mass in technically grams, but it's in kilograms. To go to particle number, I have to go through moles, okay? So I'm going to first convert mass into moles and moles into particles, okay? So I have 0.0525 kg. Well, first things first, I do want to convert that kg into grams. So 1 kg is 1,000 grams. That way kilograms and kilograms cancel out. Now you're going to do, now I'm at mass. I have mass in grams. Now I'm going to convert it to moles. I have already written here my grams per mole. So I know that 176 grams is 1 mole. That way, grams and grams cancel out. Then 1 mole is 6.02 times 10 to the 23rd particles. Now I've canceled out mole and mole. Now I have my numbers, all my numbers, right? I have just my numbers, which I have to do some basic calculation and multiplication and division on the calculator. And then my final answer should be 1.81 times 10 to the 24th molecules of K2SO4. That is your final answer. Next topic. So the last topic I really want to go over quickly with you guys is the concept of volume. Just like how Avogadro's number says that 1 mole is 6.02 times 10 to the 23rd particles, that's the same concept how 1 mole of any gas is 22.4 liters. So let's do a question for volume. This question number 4 is saying, what is the volume in milliliters of 4.75 times 10 to the negative 6th moles of oxygen gas, or O2? A little rule of thumb, anytime it says something gas, it's meaning a diatomic molecule, meaning O2 or Cl2 is chlorine gas, Br2 is bromine gas, I2 is iodine gas, etc., etc. So the way that you solve this question is honestly really simple. As you can go back to my table that I had written out for you guys, if it's asking for volume and in the question it gives moles, it's a real simple one-step calculation. It's just 1 mole is 22.4 liters. So the same the same concept goes for number 4. When it says, what is the volume in milliliters of this? So I'm going to start out my dimensional analysis table by saying 4.75 times 10 to the negative 6th moles. And I know 1 mole is 22.4 liters. But the answer is in milliliters. That's why, well, mole and mole cancel out and I'm left with liters. But I want to bring it to milliliters. So I'm going to write that 1 liter is 1,000 milliliters, meaning that liter and liter cancel out and I'm left with milliliters. And I'm left with my numbers, which is just simple multiplication. And your final answer should be 0.1064 ml. That is it. That's all that we're going to be doing for today. Stay tuned for another video. We're going to be talking about empirical and molecular formulas. And I'll catch you on the next one. If you guys have any questions, feel free to DM me. I am always free. Thank you so much for watching. Have a good night.